Okay, now summary. Usually Bayesian classifier is a very fast technique. If we are going to say it later on, neural networks, it takes time. But this one is usually in one pass, in several passes, you can get the complete probability table that you need to determine the class of the new data. Just the computer, right? For less than 30, compute the probability. For greater than 30, compute the probability, etc. But just one pass, you can do it. Basically, what you are doing is, since if you know the number of possible attribute values, as you go along your table, you put a counter, you increase its count there. And then whenever you are done at the end, you know the count per attribute value, and then you can just find this probability directly. So it is a very fast technique because of that. Model is simple, all right? So you just need a probability distribution. What I mean model, okay, you need to say what is the model here. I come back. Model will be composed of these probabilities. You see, for each attribute, for each class, per class, we need to find the probability plus the probability of each class. So this is the model. That's what we mean. And error is minimized based on the assumptions, okay? So we had many assumptions. One of them is we assume the probability of a specific class, right? So that's an assumption. And we also have somewhat assumption on the probability of X given a class. And in addition, we also assume that attributes are independent. Easy to implement, good results obtained in many cases, robust to noise. If you have a noise, what's going to happen? It's incorrect value. It's just going to affect, it's going to have a minor effect on the probability. That's it. It's incorrect value, it doesn't matter. So it's, let's say, labeled incorrectly. It's just one data. It's not going to have a significant impact. And you may ignore the missing values. You can just count the rest. You are still going to have a probability. If something is missing, just count the rest. And now you are going to have one less for that one. You can still work on it. So it's easy to handle that one. Robust to irrelevant attributes as well. So it's not going to be affected. And usually assumes a normal distribution of patterns. Okay. These are some difficulties. Is the most likely answer always the best? Not always, because cost of errors might be different. So we are going to see this later on. An independence assumption may not hold some attributes. So there are graphical models, which I am going to show very briefly, but I'm not going to go in details of those. And this is incremental too, okay? What I mean by incremental, so you train your data set, okay? Let's say you have 10,000 data, and then someone else give you 500 more, okay? Just count to 500 more, and then you can compute it directly. You don't need to go from the beginning. If you know the count, you just need to count a new 500. Check the values over there and just and add them up to the previous model. You are going to get it. It's a good property. Okay. This is the graphical model. All right. So before this is the last one about this Bayesian classifier. Do you have questions?